Alright, today we're going to be talking about similar polygons. You need to have your workbook out and turn to page 155. This is where you'll begin to take notes. Okay, so if you don't have your workbook out and you don't have it turned to page 155, pause until you do so. Alright, taking a look here at these pictures, these are all pentagons, and they are all regular pentagons, meaning all their angles and all their sides are the same length. Now, obviously, this pentagon is nowhere near the size of the actual pentagon, if you would, in Washington, D.C. Okay? This may be, what, maybe 2 inches, and what's this going to be? Hundreds, 200 feet, maybe? I'm not exactly sure the exact amount. But while these pentagons are not congruent, they are similar because they both have the same angle measures. They're all going to be 72 degrees. Alright, so 2 polygons are similar if and only if, remember by conditional, their corresponding angles are congruent and the corresponding side lengths are proportional. Okay, the similarity ratio is the ratio of any side length in the first figure to the corresponding side in the second figure. So if we take a look here, we have these 2 rectangles, okay? Now we know they're rectangles because they tell us, for 1, and for 2, we have opposite sides congruent with all 90-degree angles. So we need to determine if they are similar. So we're going to do the ratio of BC to XY because those are the corresponding sides. So that would be 16 over 10, okay? And that's going to end up simplifying to 8 over 5, or as a decimal, 1.6. Now, we need to check the other side. So let's check AB, which corresponds to WX. So 12 over 7.5, which as a decimal is 1.6. Because the ratio of all the sides is the same, then these 2 are going to be similar. They are similar. Now, you're probably wondering why I didn't check AD and WZ. Well, AD and WZ is going to be 16 over 10. It's the same ratio here as BC over XY because opposite sides are congruent. Okay, and that's also the same reason why I didn't check CD and YZ because they would have the same ratio as AB over WX. Alright, so given these parallelograms, we need to see if they are similar or not. So let's see, KL is 5. And it corresponds to PQ, so 5 over 6.25. Which if I type that in my calculator gives me 0.8. Alright, then I'm going to do KN, which is 3, and PS, which is 4. So 3 over 4 in my calculator is 0.75. Because these ratios are not the same, then these are going to be not congruent. So they are not congruent. Let me fix that. Are not similar. Excuse me, I didn't mean to say congruent. Alright, so the ratio is not the same, therefore they're not similar. Basically, the ratio would be the scale factor, and if the scale factor is not the same all the way around, then they're not going to be similar. Okay? That means we didn't do a dilation. Alright, so if you measure the angles in the 2 figures and find that the corresponding angles are not congruent, what conclusion can you draw about the figures? Okay, how is this a shortcut? So remember, if we go back to the definition of similar polygons, corresponding angles had to be congruent. So if I know that the corresponding angles aren't congruent, then they can't be a similar figure. Alright, so it says describe how to find the similarity ratio of 2 similar figures when you are given lengths of corresponding sides. So basically, you're going to take one side from the first polygon and divide it by the corresponding side of the second polygon, and that's your similar ratio. So you would do Alright, so one side divided by the corresponding side of the other equals the similarity ratio. Alright, now, it says that these two trapezoids are similar. So I know that their ratios have to be the same, and I need to find the missing side length. Okay? So it says the known length of the side trapezoid BHJC will be the numerator of a fraction, and the corresponding side length of trapezoid DEFG will be the denominator. So JC over FG. So if JC is 0.265 then and FG is 5, then my similarity ratio must be 1.25. So now what we can do is we can go back and find all of the missing sides. So do you see this right below part B? Okay, so the first one we're going to do is HJ over EF. Okay, that has to be the ratio of 1.25. Has to be. Because they're similar. In fact, all of these are going to be 1.25 because similar polygons have the same ratio. So HJ is going to be equal to 1.25 times the corresponding side EF. And EF is 3, so that means HJ must be 3.75. So 1.25 times 3 equals 3.75. Do you see how you're filling this out? Alright, BH must be 1.25 times DE. Well, if DE is 3, 1.25 times 3 is 3.75. And BC is 1.25 times DG. Well, DG is 7, so 1.25 times 7 will give me 8.75. Oops. 0.75. There we go. So that's how you would find the missing sides. Alright, now we can also call the similarity ratio a scale factor, because what's happening here is I took the first trapezoid and I gave it a scale factor and multiplied each point by 1.25. And the way that you would find the scale factor is you would take a side length from the second figure and divide it by the same corresponding side of the first figure, okay? So that would give me my scale factor. So how is the scale factor used to find unknown side lengths in the second figure? All we have to do is, once we have the scale factor, multiply it to the side, and then that would give us the corresponding side. Alright, so we take the side we know in the first figure, multiply it by the scale factor once we know it, and that would give us the corresponding side in the second figure. So suppose figure A is similar to figure B. How is the similarity ratio of A to B related to the scale factor of A to B? So when we were finding the similarity ratio, we did the side in the first triangle divided by the corresponding side of the second triangle. But then when we did scale factor, we did the second side divided by the first side. So if you'll notice, these are actually reciprocals of each other. Oops. They are reciprocals of each other. That's very important. So if you go back and look at the first page where you had to determine if the polygons were similar in those rectangles, we did the first rectangle divided by the second rectangle. And that gave us our similarity ratio. Alright, however, when we already know that two things are similar, we need to find the scale factor. So this time you go from the second to the first. So if you go back and look, and I will go back with you, there we go. You notice how this is your first figure and this is your second. So here's the thing. I know that my scale factor should be larger than 1, correct? Because I'm getting bigger. Anytime I multiply by a scale factor larger than 1, I have a bigger shape. So that's going to be very, very, very important to realize on what context of the problem are you working. Do you need the similarity ratio or do you need the scale factor? Okay? So that's going to be up to you to determine. Alright, so here we are at a checkpoint. So this is kind of that place when you're halfway through that Mario level and you tag the flag, and if something happens, you can start back at that point. Okay? So what we're going to do is we're going to pause here. You're going to work on pages 157 and 158, but go ahead and skip problem number 4. Okay? So this is your checkpoint, little Mario flag. So pause here and do those problems now. Hit play when you're ready. Alright, so it says corresponding angles in each pair are congruent. Use ratios of corresponding sides to tell whether the figures are similar, and if so, identify the similarity ratio. So here we're trying to identify if they are similar, and then if so, the similarity ratio. So remember that similarity ratio is going to be the first over the second. Alright, so we have 45 over 15 is 3. Okay, because x, y, and AB correspond to each other. Then we have 27 over 9, because those correspond to each other, and that is 3. And then the last one to check is 36 over 12. And that is 3. So because the similarity ratio is the same for all 3 sides, then they are similar. And the similarity ratio is 3 over 1. Alright, so let's go ahead and take a look at problem number 2. I need to determine if the two trapezoids are similar. Okay? So first off, I noticed right off the bat they look a little different. Like, not only is it dilated, but maybe it's rotated. So what I'm going to need to do is I'm going to need to use the letters at the top of the page. So if JH corresponds to DG, then that would be 4 over 8, which is 1/2. Alright, then I also have that KL, or LK, is corresponding to FE. So KL and EF, so that's 6 over 10, which is 3/5. That's a problem. Those aren't the same. So the answer is no, they're not similar. Okay? Alright, so now I have these polygons. They are 5 sides, so a non-regular pentagon. So let's double check. I have NB and ST. So 10 over 6 is 5/3. MN and SR are the same numbers. Alright, ME and RV, so 20 over 12 is 5/3. 10 over 6, we already did that one. And then 15, oops, not 15, excuse me. First over second, 25 over 15 is 5/3. So the answer is yes, and the similarity ratio is 5/3. Alright, now in this case, we were asked to find the missing lengths, and we already knew they were similar. So in this case, you're going to be using scale factor, which is the second figure divided by the first figure. Alright, so what we have here is we only know 14, and it corresponds to CD. So 14 over 10 is 1.4 is my scale factor. So then I take 16, multiply it by 1.4 to get 22.4. 6 times 1.4 is 8.4, and 8 times 1.4 is 11.2. Alright, so I have the only side here is 3x, and it corresponds to 2x. So 3x over 2x is 3/2, or 1.5. So all I need to do is multiply all of the sides by 1.5 to find my missing sides. Alright, so there you go. Alright, so in this problem, we already know they're similar. So all I have to do is find the scale factor, and I found the scale factor to be 3. It tells you in the problem that AED is the first triangle and ABC is the second. Alright, so all I have to do is multiply AE by 3, and I get AB as 15. 8 times 3 is 24. Alright, so on this, we already know that they are similar. Basically, the scale factor is K. If I have KB divided by B, then the scale factor is K. The reciprocal of that is the similarity ratio. Alright, that's all for today. I'll talk to you guys later.